path through which we will explore this new system. Let's first check up what do we really know, and next we will examine our foundations, and the third we select space and time, and the fourth we reset a new foundation, and the next we clarify space, time and motion, and lastly we start at the beginning. First, what do we really know? Conventional science starts with several assumptions. Let us look at some of the quantities involved in the physical sciences. For example, we have a number of fundamental physical quantities which are defined: distance, time, mass, angle, electric current, temperature, luminosity, amount. All these quantities are just quantities of different kinds. No one knows what they are made of. In other words, one cannot define space, time and other quantities in terms of simpler quantities. We rely on intuition and assumptions. Well, let us see if we can clarify this with some examples. Weighty matters. The first and most fundamental definition which any one of us would have come across during our study of physics. What is mass? And the textbook answer is, mass is the amount of matter present in a body. Now here's a point to be noted. Both matter and body in essence mean mass. Hence, this definition is nothing but a tautology. Mass is mass, and this definition is hence an assumption. The lighter side, empty space. Let's look at the definition of space according to the Encyclopedia Britannica. A boundless three-dimensional extent. And again, here we are encountering the same thing. Boundless and extent both use the meaning derived from the word space itself. So whatever space is, its properties are again assumed to be true and complete. Space may have other properties too, but we always start with this assumption. Time and time again. Time has always confused people right from the beginning of time. What is time? A measured or measurable period. A continuum that lacks spatial dimensions. Well, the first part uses the word period, which is nothing but time itself. The second merely mentions that time is not space. In other words, it is distinct from space. And so the moral of the story is, we make do with the existing fundamental quantities, as we do not know how to reduce them further. It is necessary that we identify a new fundamental quantity. This is the first step for a theory of the physical universe. To make sure that we understand how we are looking at the physical universe, first let's check out a conventional view completely. Mass. Something called matter exists, which is hard, measurable and resists a push. In other words, exhibits inertia. This thing exists in a setting of space. This thing also exists in time. Hence, matter exists in a background of space and time. This is our assumption about mass. Space. It has a property called volume, and it has three coordinate dimensions, x, y and z. It is stationary, that is, measurements of space itself do not change with respect to time. 5 meters would remain 5 meters today and tomorrow and ever after. We also assume a Euclidean geometry of space, at least in classical physics, and a linear nature. For clarity, we shall call this kind of space as coordinate space, because it involves the 3 coordinate dimensions. Let us look at the view of time too. The only thing we know about time is that the flow of time is registered on a clock. It is a uniform, unending progression. It is distinct from space, and there is a cyclical nature with respect to space. This is a pretty simple thing, as a clock returns to the same point after every period of time, and a clock is a spatial representation of time. Hence, we shall call it clock time. The next important thing is concerning motion. Matter moves in coordinate space in some amount of clock time. Looking at the example, we see a chap running who is at one particular point at 12:15 and who is at another particular point after 15 minutes, and the displacement of that person is what we measure in coordinate space, and the time which we measure associated with the motion is clock time. Hence, this is the old foundation on which we build our entire system of sciences. We assume that it consists of independent entities called mass, space, time, electric current, temperature, luminosity, etc. At this point, we conclude our examination of the old foundation. Now, let's put on a new set of spectacles and ask some questions. What if space, time, and matter were different aspects of the same quantity? What if the properties of space and time as we know it are just special cases? And what if the unknown properties of space and time show up in and as matter? One thing seems clear: space and time are distinct. So, this gives us the idea that they can be identified as two aspects of the fundamental quantity. Now, we know that the ratio of space to time is what we call as motion. So, we set up a new foundation in which the fundamental quantity of the universe is motion, something called motion, and from that all things come out: mass, space, time, electric current, temperature, luminosity, etc. They are all different kinds of the same quantity, motion. Hence, motion is the only thing. Since space and time are distinct aspects, let us define them in terms of the fundamental quantity. Space and time are the two aspects of motion. This will be our definition of space and time. So, every physical quantity is a motion or a combination of motions. A mass is a motion, an electron is a motion, as are heat, light, and all the fundamental forces. The theory must be able to explain the properties of all these quantities, and it does do so, as we shall see later. A reciprocal system. If you remember, this is the name of the system. So why the word reciprocal? Because we have to examine how are space and time distinct. All we have said is there are two aspects of motion. We call the distinguishing point of space and time as the reciprocal nature. In other words, space and time are reciprocals of each other. This would be described in another presentation called reciprocity. All the other properties are common to both space and time. That is the important point. So, space was originally recognized only as coordinate space. Time was originally recognized only as clock time. Now we know that space and time should have similar properties, other than the fact that they are reciprocal. So this gives us a new idea. There should also exist coordinate time and clock space. In other words, time can have 3 coordinate dimensions and space can behave like a scalar progression. These are the hitherto unrecognized properties of space and time. So now we have a generalized form of space and time. Space, one aspect of motion which includes both clock space and coordinate space. Time, another aspect of motion which includes both clock time and coordinate time. The question comes to our mind because we are speaking about space, time and motion. Are space and time primary? In other words, when we say space by time is equal to motion, do we mean that the space and time are the constituents of motion or something more primary than motion? No. Motion cannot exist without giving rise to space and space and time cannot exist without giving rise to motion. In order to illustrate, let us see some examples. The heads and tails of motion. Let us make an assumption that motion can be represented by a coin. The two sides of the coin are space and time. If you notice, there can be no sides to the coin if there is no coin. And similarly, if a coin exists, it has to have two sides. Let us look at the diagram. We have represented a coin as motion, one side as space, another side as time. The motion of the coin is motion, and one side goes to another side, which means that space and time are two aspects of the same coin. One is heads and another is tails. Which is up to us. The ins and outs of motion. Let us assume that motion is represented by a box. That would mean that the inside of the box is time or space if we want it, and the outside of the box is space or time if we want it. Without a box, there is no inside and no outside. Hence, motion implies space and space and time imply motion. These two do not exist without motion, and vice versa. Looking at the diagram will clarify the things. You have the box as motion, we have space on the outside and time on the inside, or time on the outside or space on the inside. It is very clear that neither time nor space has any meaning if there were no box. So, let us summarize the view of the reciprocal system. Motion is the fundamental quantity of the universe. It is the content as well as the container, unlike conventional science where matter is the content and space and time are the container. It has two aspects related as a ratio. These two aspects are space and time, and we cannot have either existent without motion. They are the superset of the coordinate space and clock time that we use normally. So let's start at the very beginning. With these ideas of motion, space and time, we shall look now at the postulates. These postulates are very important, the fact that they are the basis for the further development of an entire system of physical theory. In the beginning there were two postulates, and the word was motion. Basic postulate 1. What the universe is. The physical universe is composed of one component, motion, existing in 3 dimensions, in discrete units, and with 2 reciprocal aspects, space and time. Basic postulate 2. How the universe works. The physical universe conforms to the relations of ordinary commutative mathematics. Its primary magnitudes are absolute, and its geometry is Euclidean.